Hey guys, today we're looking at 5.6, which is going to talk about our half-angle identities. This is the last section for this unit. So for our half-angle identities, we've got that the cosine of A divided by 2 is equal to plus or minus the square root of 1 plus cosine A divided by 2. The sine of A divided by 2 is equal to plus or minus the square root of 1 minus cosine A divided by 2. And then this time the tangent is the one that has the three different options over here. So we've got the tangent of A over 2 is equal to plus or minus the square root of 1 minus cosine A over 1 plus cosine A. Or we've got the tangent of A over 2 is equal to sine of A over 1 plus cosine A. Or the tangent of A over 2 is equal to 1 minus cosine A over the sine of A. So let's get some practice using these. It says, for example 1, find the exact value of the cosine of 15 degrees using the half angle identity for cosine. Now, when you get to your test, make sure that you're paying attention to the directions. We do have some different options for how we could find the cosine of 15 degrees. You could use your sum or difference identities, but this one specifically says using the half angle identity. So if your directions don't say to do a specific identity, you can use whichever one you would like, but because this one does specifically say using the half angle identity, we're going to use the half angle identity here. So if we're trying to get to 15 degrees, we need to figure out what we are dividing by 2 to get to 15 degrees. So if I'm looking at that, it would be 30 degrees that I have to divide by 2 to get to 15 degrees. So that means that my A value is going to be 30 degrees. So that's what I'm going to keep in mind when I'm looking at my identities, that A is 30. We are trying to find the cosine, so that means that I am looking at this first identity right here. So that means that I'm going to have that the cosine of A over 2 is equal to plus or minus the square root of 1 plus the cosine of A all over 2. Okay, we just said that A is 30 degrees, so that's what I'm going to plug into my formula. So that means I'm going to have plus or minus the square root of 1 plus the cosine of 30 degrees over 2. And the cosine of 30 degrees is on my unit circle. So that's kind of why we would use that 30 degrees there. If I'm looking for the cosine of 30 degrees, that means that I would have plus or minus the square root of 1 plus, and then that would be square root of 3 over 2, all over 2. Now notice we do have a plus or minus here, and so this is where I need to pay attention to what quadrant I'm in to figure out if I am going to use the plus or the minus. We are looking at the 15 degrees, and that 15 degrees is going to be over here in quadrant 1. So using my all smarties, take calculus, everything's going to be positive, so I'm going to take the positive version. And then I need to start simplifying this. I don't really want a fraction within a fraction. I don't want that big square root over the fraction, so I'm going to start cleaning some stuff up. What I can do here is I can multiply everything in the top by 2 and the bottom by 2 to kind of clean up that fraction within a fraction part. So that means I'm going to have the big square root of 2 plus the square root of 3 when I distribute on the top, and then 2 times 2 on the bottom is 4. And that also helps me clean up the big square root part because I can take the square root of the top and the square root of the bottom separately. So I'm going to have the square root of 2 plus the square root of 3 on the top. And on the bottom, if I have the square root of 4, well, that's just 2. So then I've cleaned it up, and that's my answer. It doesn't look super nice on the top because I've got a square root within a square root, but I don't have a square root on the bottom, and that's really what I needed to fix there. So there's my answer. All right, example 2 says to find the exact value of tangent of 22.5 degrees using the identity tangent of A over 2 is equal to sine of A over 1 plus cosine A. So it even tells us exactly which of the half angle identities it wants us to use here. So once again, I'm going to come over here on the side and I'm going to try and figure out what my A value would be. So if I'm looking for 22.5 degrees, I need to figure out what A would be. A over 2 has to equal that 22.5 degrees. So I'm going to multiply both sides by 2, because this one's not as easy to see right off the bat. When I multiply both sides by 2, I get that A is 2 times 22.5, which would be 45 degrees. So when I plug it all into my formula over here, that's what I'm going to plug in for A. So I'm going to have the tangent of A over 2 is equal to the sine of 45 degrees over 1 plus the cosine of 45 degrees. And 45 degrees is on my unit circle, so I can look at my unit circle to help me simplify that. The sine of 45 degrees is going to be the square root of 2 over 2, and then 1 plus the cosine of 45 degrees is also the square root of 2 over 2. Same thing as example 1. I don't want the little bitty fractions in my big fraction, so I'm going to multiply by 2 over 2, so top by 2, bottom by 2, to clean this up a little bit. And the top, that just cancels out that denominator, so I get the square root of 2 in the top. In the bottom, when I distribute, I get 2 plus, and then it cancels out that denominator, square root of 2. Now I can't have that square root in the denominator, so this is where I'm going to have to multiply by a conjugate because it is 2 plus the square root of 2. So the conjugate of the denominator that I'm going to multiply by is 2 minus the square root of 2. So when I multiply by all of that down here, well, on the top I just distribute. So 2 root 2 minus, well, if I have the square root of 2 times the square root of 2, that's just going to give me 2. But on the bottom here, I got to FOIL it out. So first times first, 2 times 2 is 4. Outside times outside is going to give me minus 2 square root of 2. Inside times inside is plus 2 square root of 2. And last times last is going to give me minus 2. So cleaning up that bottom part, I get, well, 4 minus 2 is 2. And those inside parts just cancel. So I have 2 square root of 2 minus 2 all over 2. So all of that is going to divide, and I just get the square root of 2 minus 1. And that would be my answer. And then just like all of the other identities that we've looked at, this can go the other way around. I can already have the square root side, the kind of expanded side, and go backwards to find what the half angle is. So if I'm looking at example 3, we've got 1 plus the cosine of 12x over 2. So I'm going to come up here and I'm going to look. If I'm looking at my tangents, none of those have 2 as a denominator, so that means I'm looking at either the cosine or the sine. If I look at my example 3, I do have 1 plus that cosine of 12x. So up here, if I'm looking at those, that matches with my sine. Isn't not sine, sorry, sine is subtracting, that matches with my cosine. I was thinking about sine because I was crossing it out. It matches my cosine because we're adding, not my sine because we're subtracting. So that means I'm looking at the cosine of a over 2. So this matches with cosine. And then from here, I just need to figure out what my a is. Well, your a is what's in here. So my a is 12x. So that means I'm trying to find the cosine of 12x divided by 2. So that means I'm trying to find the cosine of 6. And there's not really anything else I can do to simplify that since I don't know what x is. Okay, same thing. I'm going to look at example 4 here. It says simplify the expression. I've got 1 minus the cosine of 5 alpha over sine of 5 alpha. So I'm going to look up here and see if that matches with anything. It kind of looks like my tangents over here. So I've got one where it's the sine of a over 1 plus cosine a, and one where it's 1 minus cosine a over sine a. So it matches with this bottom one here. So that's the tangent of a over 2. I just have to figure out what that a is. So if I'm looking at the tangent of a over 2, Well, I'm going to look at what's inside the cosine and inside the sine, and that's going to be what my a value is. So it's 5 alpha. So I'm going to look for the tangent of 5 alpha over 2. And the 5 over 2 doesn't really simplify, so that's it. There's my answer because I don't know what alpha is. Alphas kind of look like fish, but it's supposed to be an alpha. Excuse my bad handwriting, sorry. And then we can also use these to help us verify some identities. So that's what we're going to look at example 5. We've got an identity here. So remember, when we're verifying identities, we're only working one side. Generally, you want to start with the side that's a little more complicated. So I would start with the left side because it's got the x over 2 inside the sine and the cosine, and it's squared, whereas the right side is just 1 plus sine x. So that's kind of what I would look at. If we're talking about something being squared, that means that we've got to write it twice and FOIL it out. So I would say sine of x over 2 plus cosine of x over 2 times sine of x over 2 plus cosine of x over 2. So if I have first times first, that's going to be sine squared of x over 2. Outside times outside is going to be sine of x over 2 cosine of x over 2. Inside times inside is the same thing. Sine of x over 2 cosine of x over 2. Running out of room, so I'm going to scoot that over. And last times last is cosine squared of x over 2. I'm going to combine some of my terms here. Right here, if I've got two of these, I can write that as 2 sine of x over 2 cosine of x over 2, then plus sine squared of x over 2 plus cosine squared of x over 2. And then I'm going to start thinking about some identities that could help me here a little bit. So we do have an identity for sine of x over 2. We've got an identity for cosine of x over 2. And then I'm also going to notice right here that I've got a sine squared plus a cosine squared, and that's a Pythagorean identity. Remember, a sine squared plus cosine squared equals 1. So this part is just going to change to plus 1. And then I'm going to use my half angle identities for sine of x over 2 and cosine of x over 2, which is up here at the top of our notes. So we've got these right here. They do have the plus or minus with them. When we're talking about verifying identities, we don't really need to put the plus or minus inside of that. Also, because we squared and all of that, the plus or minus would end up kind of going away. So I'm going to say 2 times, 2 times, and then for the sine of x over 2. So remember, that is our first one. So that is the square root of 1 plus cosine x over 2. And then the cosine of x over 2 would be the square root of 1 minus cosine x over 2. And then, yeah, technically they would have plus or minuses here. But for the sake of verifying, you can kind of drop those. The other thing that's going to happen here too is if they're all in a square root right there, I can make it one big square root. So I can say 2 and then the big square root, multiply across the top, so 1 plus cosine x times 1 minus cosine x. And on the bottom, 2 times 2, 2 times 2 is 4. And then still the plus 1 behind it. And then I've got another expression there that I can FOIL out. I'm kind of running out of room. So I'm going to bring it over here. So I've got the 2 in front, And I'm going to do the square root. And then first times first is 1. Outside times outside would be minus cosine x. Inside times inside would be plus cosine x. And last times last would be minus cosine squared x. And then the bottom is the square root of 4, which is just going to simplify down to 2. And give myself enough room here. Behind that is still b plus 1. So ran out of room, just brought it up here. So what's going to happen here is that this 2 and this 2 are going to cancel out. Also, this minus cosine and plus cosine are going to cancel out. So I have the square root of 1 minus cosine squared x and then plus 1. And then you'll notice 1 minus cosine squared x also relates to our Pythagorean identity that we looked at earlier. Remember, if I have sine squared x plus cosine squared x, that equals 1. I can manipulate that, subtract the cosine squared x, so I get sine squared x is equal to 1 minus cosine squared x. So I can substitute that in, square root of sine squared x plus 1. And then those square roots and squareds are going to cancel, so I get sine of x plus 1, which matches with what I was trying to get over here. So we have verified our identity. Then our last example down here says, given cosine of s is equal to 2/3, with 3 pi over 2 less than s less than 2 pi, find cosine of s over 2, sine of s over 2, and tangent of s over 2. So let's start with that cosine of s over 2. So remember, looking at the front of our notes, our identity that matches with that is the cosine of s over 2 is going to equal plus or minus the square root of 1 plus cosine of s over 2. Well, we know what cosine of s is. It tells us right here cosine of s is 2/3, so I'm going to plug that in. The cosine of s over 2 is going to equal plus or minus the square root of 1 plus 2/3 over 2. I don't really want that little bitty fraction inside there, so I'm going to multiply top and bottom by 3. When I do that, I get that the cosine of s over 2 is equal to plus or minus. Distributing on the top, I get 3 plus 2 over 2 times 3 is 6. So the cosine of s over 2 is equal to plus or minus the square root of 5, 6. I can split that, so I have the cosine of s over 2 is equal to plus or minus the square root of 5 over the square root of 6. And then I have to rationalize the denominator, so multiply top and bottom by the square root of 6. So I get the cosine of s over 2 is equal to plus or minus the square root of, well, 5 times 6 is 30 over 6. The problem here, though, is that in every single one of those steps, I've had a plus or minus. And I need to figure out, is it plus or is it minus? So that's where this nice little inequality is going to help me out. So I'm going to come over here on the side. If I know that 3 pi over 2 is less than s, which is less than 2 pi, I need to kind of manipulate that so I can try and figure out where s over 2 would be. So if I'm looking for s over 2, what I'm going to do is I'm literally going to divide everything by 2. So 3 pi over 2 is going to give me 3 pi over 4. S over 2 is what I'm trying to get to, and 2 pi over 2, well, the 2's cancel and I just get pi. So then I need to figure out what quadrant that's going to be in. So if I'm looking 0, this one's pi over 2, pi, 3 pi over 2. Well, now I am 3 pi over 4 is less than s over 2, which is less than pi. So when I'm looking at this, well, 3 pi over 4, that's up here in quadrant 2 in pi. So it's somewhere in between here and here. So it's somewhere in this section right here, which is quadrant 2. So then I can use my all smarties, take calculus, and I know that it's going to fall in that quadrant 2 interval. So the S stands for sine, so that means for this first value, my cosine, it's going to be negative. So the cosine of S over 2 is going to be negative square root of 30 over 6. And now from here, I can move on to the next one. Now I need to find the sine of S over 2. So looking at my identity up here for sine, let me section this off. Sine of S over 2 is plus or minus, and this time it is 1 minus cosine S over 2. Now, I already know that we're going to be over here in quadrant 2, where S stands for sine, so I know sine is going to be positive, so I can go ahead and fix that plus or minus part right now. It's going to be positive, so I can say sine of S over 2 is going to equal the square root of 1 minus that 2/3 over 2. And I'm going to follow similar steps to what I did for my cosine. So I'm going to multiply the top by 3 and the bottom by 3. So I get the sine of S over 2 is equal to the square root of 3 minus 2 over 6. So the sine of S over 2 is equal to the square root, well, 3 minus 2 is 1 over 6. When I start simplifying this, if I take the square root of the top, the square root of 1 is just 1 over the square root of 6. And then I can rationalize my denominator. And I get that the sine of S over 2 is equal to the square root of 6 over 6. And then the last part that I need to find is my tangent. Now, there's a couple different ways that you can find your tangent. You can use one of the identities up at the top of the notes. So up here for the tangent, I've got this one, or this one. If I'm looking at this, I know cosine. I don't know what sine is, so I probably wouldn't want to use this one or this one that has sine in it. I'd probably want to stick with that first one that just has cosine. So I'm going to come back down here. Since I know what cosine is, I'm going to use that first one. I'm going to say that the tangent of S over 2 is going to equal plus or minus the square root of 1 minus cosine of S over 1 plus cosine of S. And then I'm going to plug in the cosine I know and start simplifying it. So cosine's 2/3, so that means that the tangent of S over 2 is equal to, oh, I also know I'm in quadrant 2, so only sine is going to be positive, so this is going to be negative square root of 1 minus 2/3 over 1 plus 2/3. I can multiply the top and the bottom by 3. So the tangent of s over 2 is equal to a negative square root of 3 minus 2 over 3 plus 2. So the tangent of s over 2 is equal to negative square root of 1 over 5. Tangent of s over 2 is going to equal, well, the square root of 1 is just 1 over the square root of 5. And rationalize that denominator. So I get that the tangent of s over 2 is going to equal negative square root of 5 over. Another option that you could have done here is you could have used your quotient identity. I could have done my sine over my cosine, but the, the gamble there is what if you got your sine wrong? What if you got your cosine wrong? So by using the identity, I'm guaranteeing that I'm using a cosine of s that I know the value is correct because it's the value they gave me. So just be careful with that. You're more than welcome to use the quotient identity if you're very, very confident with your answers, but this just guarantees that you're using something you know is correct. Right, that's it for this set of notes. Make sure you get started on your assignment that goes with this. Let me know if you have any questions, and y'all have a good day.